Hi, physical science students. Today I'm looking at the F equals MA worksheet, and I'm going to go through some of the problems here, not all of them, and basically what we're doing is using Newton's second law, which is F equals MA. But again, we can write it in this form, and that allows us to solve for any of the three variables if we know the other two. So I'll go through a couple example problems here where we find the different variables based on what we already know. So, and I will also go through showing you how to show your work and go through the 5 steps like we always do. So the first question, how much force is required to accelerate a 2 kilogram mass at 3 meters per second squared? So the first thing we're looking for here is force. And it says it's how much is required to accelerate a 2 kilogram mass. So a 2 kilogram mass, that's our M. And then we have 3 meters per second squared. 3 meters per second squared represents an acceleration. All right, so I've got my unknown, I have my 2 known variables, and now I need an equation. And that equation is F equals ma. So that's step 3. Step 4, let's do our substitutions. So I go 2 kilograms times 3 meters per second squared. And 2 times 3 is 6. And what are the units of force? Units of force are newtons. Again, we know from our last worksheet that if I carried the units over in the problem, kilograms, meters, and seconds squared, I would get kilograms, meters per second squared because none of those things cancel out. But scientists have combined all 3 of those into the unit called the Newton. And notice that this is just this is the general case of the weight problems that we did. Before we had F equals mg. G is an acceleration, but it's a very special situation because it's always the same here on Earth. But Newton's second law, where we use A, acceleration can be anything because it's not just due to gravity. All right, let's look at number 2 now. Number 2, given a force of 100 newtons, so that's our F, and an acceleration of 10 meters per second squared, that's our A, what is the mass? That's our question mark. So I come up here, I need an equation. I'm looking for M. M is equal to F over A. And now I substitute. What goes in for F? 100. What goes in for A? 10. And 100 divided by 10 is just 10. And the units of mass are the kilogram. All right, number 3. What is the acceleration of a 10 kilogram mass pushed by a 5 Newton force? So what is the acceleration, A, of a 10 kilogram mass pushed by a 5 Newton force? Unknown, known, known. Now I need an equation. A equals F over M. And so that's going to be 5 newtons divided by 10 kilograms. 5 divided by 10 is 0.5. And what are our units of acceleration? Meters per second per second. So the rest of these problems are pretty similar. I'll just go through the next 3 here and just identify the variables. So number 4, given a force of 88 newtons, that's an F. An acceleration of 4, that's A. What is the mass? That's our question mark. For number 5, how much force is required? Again, looking for F. We have a 12 kilogram mass and a 5 meter per second acceleration. All right, number 6. Given a force of 10 newtons, an acceleration of 5, what is the mass M? And so again, you're going to have to use a different form of the equation, one where you solve for m. And you can see that back in number 2. And really, just going through all these problems, they're very similar to one another, just different numbers. Let's go to number 19. An object moving with constant velocity has an unbalanced force applied to it. All right, let's look at that first sentence there. What does that mean? So we have an object moving with a constant velocity, meaning there is no net force on it. So here, net force equals 0. But then someone applies an unbalanced force to it. And we know that according to Newton's first law, it is going to accelerate in whatever direction that unbalanced force is. So if the unbalanced force is 20 newtons, that's our F in the math now, and the mass of the object is 3.75 kilograms, what is the acceleration of the object while the force is acting? So lots of words here, but it's really just like the other problems we did. We have A, M, and F, and then you're going to have to figure out what equation do I use here? How do I solve for A? Number 20 is, again, very similar. Number 21 has one little twist to it. A 7.5 kilogram object, so that's a mass, is placed on a scale on the surface of the planet Nerdo. If the spring scale reads 78.4 newtons, so that's a force, what is the acceleration of gravity on Nerdo? All right, so you can solve for A, or you can understand that it's the acceleration of gravity. So you could say, really what this question is asking is, what is G on the planet Nerdo? It doesn't matter. You can use either one of these equations because A and G are both accelerations. This is just being specific to know that it's the acceleration due to gravity. But the F and the M will be the same for each, F and M will be the same for each of these. You're just solving for A or G. Regardless, you're going to get the same answer.